Before we start this video, a large thank you to Dan, Brian, Connor, and Agla for their support on Patreon. I hope you guys enjoy the video. And an immense thank you to Halo Burner and Sora Stratos for their immense support to the channel this month on Patreon. I genuinely appreciate it, guys. I hope you enjoy the video. Hello everybody, and today we're going to add pivoting to our AI characters, and we're also going to make it so the animations kind of sync with the network position so it doesn't look like you're sliding. So to keep this very simple, I'm going to make another animator controller by duplicating the humanoid one, and I'm just going to do this because I'm going to make an AI character that's different from our standard character. You don't got to do this. You can just keep a humanoid character if you want to process with the video. I'm going to delete all the attacks in here. I'm going to keep the falling animation because that's going to be the same. And yeah, that's really it. I'll keep the hit reactions too now, for now. I'm going to delete the locomotion one-handed and two-handed from locomotion, and I'm going to change locomotion to just locomotion instead of one-handed weapon, and idle to just idle. And I'm going to put in some new animations I got. So I'm going to be using the zombie animation pack. This isn't out yet. It's going to be on our asset page, though, if you guys want to use it as well. It's just going to be some enemy animations for attacks and locomotion damage and stuff. So I'm only going to do a 1D movement tree, not 2D, because this enemy is not going to have any strafing. We'll get into strafing enemies in advanced AI in the future, but for now we're going to set up a very simple AI enemy that will follow you around, just try to kill you, and just do some stuff. So we'll use the 1D blend tree. We're going to have walk forward, like as before, with on the 0 threshold and 0.5 of the vertical, because remember, there's always movement when you're in the blend tree. If you're idle, you're going back to the idle state. And then I'm just going to add a run and a sprint, and I'm going to put that at 1 and 2 on the vertical. So again, you can use whatever animations you want. Miyexmo has a lot. I'm just going to use these undead animations because it kind of gives the AI character a much different feel than the standard character. And I want my enemies in this tutorial to feel a little bit different, so we're going to go ahead and do that. So I'm going to drag in these turns now, and I have here a bunch of turns. So there's a couple ways we can do this. And by do this, I mean pivoting our AI. So the first option we have here is to basically play an animation, like a pivot animation. And we don't want to use the root motion. And what we do is we just manually, with code, rotate the AI character towards its target. And you can do this over time with a code routine, or you can handle it some other way. You don't want to instantly snap to the rotation because that will be a little bit odd. You can play a different type of animation for how far you think you're going to rotate, but the benefits of this is you can really get away with using one animation, and then you can just use that one animation and then do all the rotation with the code. The downsides are it doesn't look as cool all the time, and if you don't set up multiple animations for the distance that the character needs to rotate, it can look a little bit odd. But it does work very well, and it's great for prototyping, and you only ever need one animation if you want to start with it, so that's cool. Option 2 is the option that I use in my project, and the option I'm going to showcase here in this tutorial is basically we're going to calculate the angle of the target in respect to the character, and then we're going to use that calculated angle to determine what pivot or turn animation should be played, and then we're going to play that animation with root motion so the animation handles the movement for us. So for example, if you're to the left of me at, so and so degrees, then I would turn left 45 degrees. If you're to the left of me, say 90 degrees, I'm going to turn left 90 degrees. And then if you're to the right of me 90 degrees, I'll turn right 90 degrees. So basically the animation here is doing all the work. Now it's never going to be exact, but it's going to be within the ballpark of like you're facing the target. And this is just purely preference, but I like it better when you don't always exactly face the target. I personally like the little element of randomness when you turn and pivot. So just pick whatever resonates with you the most and pick whatever you like for your project the most. Again, you don't need all these animations, and you can find whatever you need for free at Miyexmo, especially if you're prototyping. Don't worry about it now. What I'm trying to say is don't be afraid to put any old animation there, especially if you're prototyping. You don't need stuff that looks really awesome right now. You can always come back to that at any time. As long as you get the functionality in there, that is what is most important. This is especially true when you're prototyping and things are subject to change. Okay, back to the video. Okay, so I'm just going to drag in all my animation states in here now and give them a name. I'm just going to put them all up here in the animator on my AI characters animator controller. And I'm going to go into the world scene now. I'm going to take in the dummy prefab and drop him into the scene. And I'm going to make him face away from us when he spawns in. Just rotate him here to face the wall. I'm going to copy the transform component up here and then paste it in the prefab so that when he spawns in the world, he spawns here facing the wall away from us. I'm going to do this so I can show you why I think pivoting is very important and why it looks nice in a project. So I'm going to delete this prefab, jump back to the game here. Now if I walk over to him, he can't hear us because we don't have sound in the game yet. But if we had sound detection right now, he would try to turn around and target us. So to emulate that, I'm going to drag our character into his target. And watch what happens when we become a target when he's faced away from us. You can see here he's just going to basically circle around like that. It looks a little bit odd. So if he could pivot right there, it makes sense for him to turn around first and then face us. Likewise, in the pursue target state, you can kind of always just stay perfectly behind them, and they just kind of will walk forward like this and turn around. Again, not a big deal, but it's just something we can improve on, so let's do that. Let's go now into the AI character combat manager, and where we actually set the target, let's go and actually do some more additional logic. What we want to do after we set the target for the first time is actually call a function that we don't have yet called pivot towards target. And we're going to just basically make that require an AI character manager variable, because we can actually call that function too later on from other states if we want to, and reference in here from the script. So let's actually write that function now. Let's make a private or public void for pivot towards target. And then let's start writing some logic in here. So what's the first thing we need to do? And I'm going to make that public because I just actually said we're going to call that from other states in the future. The first thing we need to do is actually get an angle with this function that's going to be used to determine where we're going to pivot towards. So we're going to make a comment here, play a pivot animation depending on the viewable angle of the current target. All right, so how are we going to get that? Well, viewable angle right there, that's the key word. Let's actually make some functionality to get that angle of the target in respect to the position of our AI character. So I'm going to make a header here called viewable angle. This is on the AI character combat manager because I would consider this a combat thing. It's the angle of our current target. You can put it wherever you want, whatever makes most sense to you. Let's make a header for target information. Let's make a public float for viewable angle. Now, let's go over to the AI character manager because we only want to update this if we actually have a target. So I'm going to consider this state machine logic. So I'm going to put it inside the process state machine. I'm going to make an if statement right under where we reset our nav mesh agent. I'm going to say if AI character combat manager current target does not equal null, well then we know we have a current target. So let's actually get some information on the viewable angle. So let's say AI character combat manager viewable angle is equal to, and we're going to set up a function for this on the world utility manager. So let's do that. So let's say world utility manager instance get angle of target. We're going to make it require a transform and a direction. So the transform is simple, just pass the transform of the character, the AI character, and we're going to pass target's direction, which doesn't exist yet. So let's make that exist. We can actually store that too on the AI character combat manager because we'll use that in the future a lot more. So let's make a public vector3 target's direction. And again, this is just the direction of the current target in respect to the AI character itself. So we can get that by saying, and we're going to reference the target's direction variable now in the AI character combat manager. So we can set that variable by saying AI character combat manager dot target's direction is equal to AI character combat manager dot current target dot transform dot position minus the transform dot position of this AI character. And that's it. So now let's go over to the world utility manager scripts and let's actually write that function. Let's make it a public float because it's going to return a float all the time. That's going to be the angle that it gives back. And we could say get angle of target. Again, make it require a transform and then make it require a direction. So a vector3. And we're going to call the transform character transform as in the transform of the AI character that's called in this function. And then the target direction is the direction of the target that we have stored on the character combat manager. So let's make the direction dot y equal to 0. We only want to get the information on the basically the left and right field. There's no up and down information. So we're going to have a float for the viewable angle. We're going to say that's equal to vector3.angle character transform.forward and the target's direction. Then we're going to have a vector3 cross is equal to vector3 cross between, again, the character transform.forward and the target's direction. Now we're going to say if cross dot y is less than 0, then we're going to say viewable angle is equal to minus viewable angle. And then we're going to say return viewable angle. So what's going on here? Why am I not just using vector3.angle? Well, vector3.angle always returns an absolute value, which means it's always going to be positive. And I want an angle to be negative in some circumstances. It can be either negative 45 degrees or positive 45 degrees. So to remedy that, I'm just using a cross here and I'm subtracting the viewable angle if the cross.y is less than 0. This in turn just allows you to get a negative angle. Okay, now that we have a way to get an angle of our viewable target, let's jump back now into the AI character combat manager. Let's just say if the character is performing an action, return and do nothing. We don't want to break out of that action and pivot, especially if you're taking damage. That could be kind of weird. Then we're going to say if AI character, if viewable angle, is greater than or equal to, we'll start by saying 20. And if the viewable angle is less than or equal to, we'll say 60. And I've already tested this in game. And in this circumstance, I'm going to say AI character animator manager play target action animation. And this for me would be turn. And I'm going to change the names of these animations actually first. Let's call them something very simple. So I'm going to have turn left 45, and I'll just fast forward, and then turn right 45. And the final names will look something like this. So I'm just going to take the first one. The first one was turn right 45. So if we're between these numbers of viewable angles, you can test this in game, by the way, by running a debug.log for your viewable angle and just checking where you want which animation to play. So if we're greater or equal to 20 and less than equal to 60, we're going to turn right 45. Now, because the way we have this set up, we can just actually do the inverse of this, and that will be turning left. So what would that be? Well, if it's greater or equal to 20 and less or equal to 60 for turning right at 45, then it will be true that if it's less than or equal to minus 20 or greater than or equal to minus 60. So we just change the operators here and change the positive values to a -1, and that will be our turn left 45. So I'll do one more just to show you, then I'll fast forward to the end of it. But basically, whenever you do your right angle, you can just make it opposite, just invert it, and that's your left angle as well. So if we do, say, greater or equal to, let's see, we'll do the 91 next. So we'll do greater or equal to 61 degrees, and then we're going to do less or equal to, we'll say, 110 degrees. This will be turn right 90. I'm just going to fix the names here because I have a typo. It's not keft, it's left. So this will be turn right 90. And again, the inverse of this will be left. So otherwise, if we have less than or equal to minus 61 instead of greater than or equal to 61, or greater than or equal to minus 110 instead of less than or equal to 110, we have turn left 90. And make sure you get all the numbers covered here. Like you want to have, like, notice how I have greater or equal than 60 and then greater or equal than 61. You don't want overlap. So after you set them all up here, you can go back now and call pivot target and pass your AI character here. And what we want to do before we actually call this one last time too is to calculate the target's direction and viewable angle again. Why is this? Because if we call this function, it's not going to get time to run. So it's not actually going to play any of these animations because there's no angle that's been calculated yet. So before we actually pass the target, let's calculate an angle here locally. We can do that by saying target's direction is equal to target character dot transform opposition. And then this viewable angle is equal to, we just call our function. Why are we using this viewable angle? Because we actually have a local variable here for viewable angle when we're looking for a potential target. So let's change that right now by renaming it because that can get kind of confusing. Let's call this angle of target, and then we can get rid of this viewable angle on this variable down here because now there's only one variable in the script called viewable angle, and it's this one up here. So we come back down here now again, and now I'm thinking about it, I'm actually going to rename this to angle of potential target to be super clear because this isn't really a target yet. So before we pass that target, and then we're setting our target's direction and we're setting our viewable angle, and then we set our target, which will then cause the pivot. Now if we go into the game, if I was making footsteps, it would trigger him to get me as a target, but I'll simulate that. And there we go, you can see he pivots around, and that looks so much nicer. So now let's address the problem of basically being able to stand behind him and infinitely run behind him without him pivoting. So go to your pursue target, say, again, this is all optional, it's just if you want this logic applied, if you don't, then don't even bother putting your project. But we can say here, after we've enabled our nav mesh, if the character combat manager dot viewable angle, this assumes you have a target of course, is less than, and we're going to reference our minimum detection angle. So let's go over and make that public. And now that I'm thinking about it, since we're using this in more than one place, it's no longer just a detection angle, but it's more like a field of view. So let's make both the minimum and maximum detection angles public, and let's change their names to, instead of minimum detection angle, we can say minimum field of view and maximum field of view. This will imply that if you're within these angles of the character, you're within their field of view range. So now if your viewable angle is less than the minimum field of view, or the viewable angle is greater than the maximum field of view, then we know that the character's target is outside of their range of sight, so we should pivot towards the current target's new location. And we can do that by just saying AI character AI character combat manager pivot towards target, and we pass the AI character. All right, we're good to go. Now, if we save that, we can actually check that out in the game. But first, I'm going to make a comment here just to say what this does very clearly. If our target is, say, outside of our field of view, then we're going to pivot to face them. Just whatever you want to write here to make it very clear what this does. And again, this is totally optional. If you don't want to do that, you just want to give them a very fast rotation speed, that's cool too. It all depends on the feel of the enemy. So just do what feels right for your game. And now if I run behind this guy here and I can just get behind him, you can see he'll stop and he'll turn around and face me. And I love that personally. I think it's really cool, especially for like slow, sluggish enemies like zombies and undead. It's super, super cool. So I'm a big fan of that. All right, so now that that's working, let's address the final topic of the video. If I go over here now, I'm actually a client on the screen and I trigger this enemy. Whoop, I got some errors. Let's address that first. Okay, so this is because we're actually running the state machine logic on a client and the server. You should only ever run the state machine logic on the server. So we're going to say if is owner process state machine. Otherwise, nothing's going to happen in here for that. We only want to basically control the AI from the server. All right, let's go back and try that again. Now I'm here connected as a client on this main screen. Now if I take the host and trigger the AI enemy here, you probably can't notice it because he's moving kind of slow right now, but there's a little bit of a slide, or there will be if there's a bunch of enemies on screen or they're moving fast. There will be a tiny bit of the slide because what's happening is the network position is fighting the animator to move the character. So you get some weird little movements, and you're not seeing it right now, I guess, because it's kind of slow, but we're going to implement a safe case in here to kind of blend between them both. So I'm going to make an AI character animator manager script. And as you could have guessed, we're going to delete our start and update function and put in a namespace as is per tradition. We're going to make this derived from the character animator manager, and we're going to apply this on our dummies that are, or our AI characters rather. So we're going to use on animator move here. And what we're going to do is we're going to call the AI character manager variable here, and we're going to override awake and call that. And we're just going to simply, if we're the owner of this character, so if this is the server, we're going to do what we normally do and just apply the root motion to the position and the rotation. So we're going to say if AI character dot is owner, and we'll just do that in here. We can make an exception if we're not grounded. We'll just let the following animations take over. We won't apply any root motion. So we'll say if AI character is not grounded, or if the AI character is not grounded, just return. That's on the AI character, not the locomotion manager. Don't know why I put it there. I might change that later. So we're going to say if we're not grounded, return. And if we are grounded, we're going to get the velocity of the current animation by saying vector3 velocity is equal to AI character dot animator dot delta position. And then we're going to simply move the AI character down here by saying AI character controller dot move, and we pass the velocity. Likewise, we're going to rotate using the animation by saying AI character dot transform dot rotation times equals AI character dot animator dot delta rotation. Okay, so what do we do down here for not the host? Well, it's identical, save for one line of code. So I'm gonna make a comment host. I'll make another comment in here client, because if you're the owner, obviously this is the server, and if you're not the owner, then this is the representation of the enemy on your screen, and you are a client connected. So we're going to do the same thing, but we're going to blend the movement by saying AI character.transform.position is equal to vector3, this is after you call the movement the controller, dot smooth damp, and we're going to pass the current transform.position, and then we're going to pass the AI character dot character network manager dot position, and then we pass the network velocity and the network smooth time. Okay, so now let's go back over into our project, and don't forget to remove the regular character animator manager from your AI character prefab and replace that with the new AI character animator manager. And once that's done, go into your game and connect as a client to a host, and just notice the animation on the character. So on the screen right now, I'm a client. I'm gonna move the host over and alert the AI. I'm gonna bring him over, and I can notice a very subtle difference even now, these slower animations. The move position is now blending between the root motion and the network position, so it's kind of getting a balance between the two. And you will especially notice this a lot more when you start getting into attacks and stuff that move the characters very quickly at once, because then the network animation is going to be trying to sync, and at the same time, the root motion is going to try to apply a position to the AI character. So there's a lot of ways to deal with that syncing of the position, and this is just one of them. We can go over a few more in the future as well. Thank you everybody for joining me here once again this week. I hope you all have a lovely weekend, And of course, a special thank you to my Patrons. It's because of you guys I get to keep doing this, and I appreciate each and every one of you so much. So once again, from the bottom of my heart, thank you. The intent was to cover the combat stance this video, but this whole pivoting thing required a whole video all on its own. And now we can always come back and use this pivot logic in other states, which we will certainly do. So in the next video, we're going to start our combat stance state logic, and we're going to get into basically selecting attacks depending on the distance from your target, the field of view, and a bunch of other cool stuff. And we'll even get into how to weight attacks so that some attacks are more likely to occur than others. All right, guys, I will see you next week.